EET 114, Chapter 26, Problem 16. Very similar to the last problem. Repeat the problem for this circuit. It's an RC circuit. Okay. So the value of E, which magically just appeared, is E equals 18 plus 30 sine 400t. So there's only one sinusoid in here, and it's just a DC value plus an AC value. Okay. So R is 15, C is 125 microfarads. Part A says find the non-sinusoidal expression for the current I. So the first thing we have to do is at DC, a current is 0 because this is going to end up being an open circuit. So it's not going to allow any current to flow because, as you know, the steady state value of a capacitor is going to be open. So I0 for the DC component. For the AC component, omega equals 400 radians a second. We have to calculate the reactance, 1 over omega C, and that ends up being 20 ohms. So the impedance would be 15 ohms minus ch20, which is this in polar form. The voltage then is going to be 30 volts. Okay, divided by the square root of 2, which is just like multiplying 0.707, and phasor form equals this. Okay, remember we took this magnitude and divided by the square root of 2. So then the current in phasor form is E, the voltage, source voltage, divided by the impedance. So it equals, you do the math here and you get 0.4848 amps, angle of 53.13. So then you have to take that magnitude multiplied by the square root of 2, which they did do here. There is no DC component, so that's 0. And then put that angle in here as so. And then multiply everything out, and this is what you get. Calculate the RMS value of the current. It's just going to be this magnitude squared divided by 2, square root the whole thing because there is no DC component, equals 0.85. Part C, find the expression for the voltage across the resistor. Again, the voltage across the resistor in steady state for the DC component is going to be 0 because in steady state, this becomes an open circuit. So there won't be any current flowing through there. All right. For the AC component, omega equals 400 radians a second. So VR equals the current times 15. Current being what we calculated up here. That equals this value right here. This 0.848 times 15 is 12.72, and 53.13 plus 0 equals 53.13. So then you convert this back to sinusoid, and you get 0 square root of 2 times 12.72 sine of 400t plus 53.13 equals 18 sine 400t plus 53.13. Part D, calculate the RMS value of the voltage across the resistor. Again, there is no DC component here, so we're going to take that 18 squared divided by 2 square root equals 12.73 volts. Part E, find the expression for the voltage across the reactive element. Again, in this circuit would be the capacitor. So DC, the voltage of the DC component is going to be 18. Why? Again, because in steady state, this is the DC component here. If we put 18 volts across this circuit, after 5 time constants, the voltage across here is going to be 18. It's going to be the same. For the AC component, omega equals 400 radians a second. V sub C is equal to the current, which we calculated up here, times 20, angle of negative 90, because that's what we calculated the impedance across the capacitor is 20. at an angle of negative 90. So when you multiply this out, this is what you get. 0.848 times 20 is equal to this. 53.13 minus 90 is equal to negative 36.87. So then you have to convert back to sinusoid. You get 18 plus the square root of 2 times 16.96 sine of 400t minus 36.87 equals this answer right here. Part F, calculate the RMS value of the voltage across the reactive element. So you use that formula again, DC component, square it, plus this magnitude squared divided by 2, do the math, 24.73 volts. Part G, find the average value delivered to the resistor. Again, the power delivered to the resistor is going to be I effective squared, which we figured out to be 0.85. They put 0.848, but probably because they rounded off up here. And then times 15 equals 10.79 watts.